All right, if you have an elevator or a part that moves straight up and down, like this piece right here, this is the elevator or part of the elevator, you need to move it straight up and down when the wheel rotates because they're connected by a string. So the way you would do that is to model it similar to what's been done here. So in order for this piece to move up and down, you want to use a slider mate connection because that allows 1 degree of freedom. If you look at the slider mate, there's one arrow, and that indicates the direction that it's allowed to move. It says along the z-axis. So it's going to stay still in the x and y direction. It's not going to spin, but it is allowed to move up and down. So you want to use the slider mate instead of fasten mate for anything like an elevator or something like that. It's going to move straight up and down. Now, we need to connect that, associate it to what's spinning around. So you need to find the revolute mate that's going to cause it to move up and down. So it's revolute 2 right here. I can see it. So what I'm going to do is call it a rack and pinion relation. So one spins and the other goes straight. So rack and pinion relation. And now I need to select the 2 mates. The first one is the slider mate. Well, actually, I'm going to select the revolute mate first. So revolute goes first, and then the slider mate goes second. And then the distance per revolution is how much it moves every time you rotate. So you'd have to do a little bit of math to get that dialed in. I'm going to hit check. I'm just going to go with the default. And what you'll see now is if I click on the circle and I rotate it, the elevator starts to move upward, right? Which correctly reflects the motion if they were connected by a string.